10.3 notes, polar coordinates, page 3. So let's take a little bit of what we did on page 2 and see if we can apply this. Example 4 asks us to find the rectangular coordinates of each point. Okay, so I have got r and theta in both these cases. I've got the degree symbol in the first, in A, so I know that's an angle. And in B, I've got 3 pi over 4, it's written in radians, I know that's an angle as well. So there are some things you can look for if it doesn't tell you specifically whether it's in rectangular or polar form. These are both in polar form, we want to write them in rectangular. So what I'm going to do up here is jot a note for myself. I know that I can find an x-coordinate using r and theta and the formula r cosine theta. I know I can find the y-coordinate using r and theta because y equals r sine theta. And so that's what I'm going to do here. X equals 5 times the cosine of 300, which is 5 times 1/2, which means my x is 5/2, or 2.5. My y is 5 times the sine of 300. 5 times, remember 300 is in quadrant 4, so this is negative square root of 3 over 2. I get negative 5 square roots of 3 over 2, and my rectangular coordinates are 5/2, negative 5 square roots of 3 over 2. There are my rectangular coordinates in exact form. If you need to convert that to a decimal, crank that into a calculator and you are good to go. So let me move these little dudes up out of the way here. So we can take a look at B, change color so we can separate these out a little. But I'm going to use the exact same formula. I've got x equals negative 3 times the cosine of 3 pi over 4. 3 pi over 4 is in the second quadrant, so I've got negative 3 times negative square root of 2 over 2. That gives me an x of 3 square roots of 2 over 2. Y is going to be negative 3 times the sine of 3 pi over 4. Negative 3 times a positive square root of 2 over 2. I get negative 3 square roots of 2 over 2. So here my rectangular coordinates are 3 square roots of 2 over 2, negative 3 square roots of 2 over 2. And again, if you are plugging that in to WebWork, you may need to convert that to a decimal, in which case you need to make sure that you've got, sorry, my numbers don't look right. We get here a 2.12 if it's rounded to 2 decimal places, negative 2.12. So be prepared for both. 5 wants us to find the polar coordinates of each point. Okay, so let's take a look at what we have that converts from rectangular to polar. The most useful are going to be the fact that r squared is x squared plus y squared. So r is going to be the square root of x squared plus y squared. Sometimes we have to consider whether it's positive or negative. When we're looking for that magnitude, the length of that r, it's always going to be positive. And then the other piece we're going to use is our theta equals inverse tangent of y over x. So starting with example 5a, x is negative 3, y is 3. So r squared, now let's not even go with the squared part. R equals the square root of negative 3 squared plus 3 squared, square root of 9 plus 9, which is the square root of 18, which we can reduce to 3 square roots of 2. 18 is 9 times 2, 9 is a perfect square, so there's our r. Theta is the inverse tangent of 3 over negative 3, so the inverse tangent of negative 1. Think about where this point is plotted. So hang on a second. So we know that inverse tangent is 1 or negative 1 at all of our pi over 4s. We know that this is going to be in the second quadrant. If I plot this rectangular wise, I've got negative 3, positive 3. This puts it in quadrant 2, which means that we should be talking about an angle that's also putting it in quadrant 2. This does not, nothing changes because we're going from rectangular to polar. And so that angle we know is 3 pi over 4. So the polar coordinates here are 3 square roots of 2, 3 pi over 4. B, we're going to go through the same thing. R is going to be the square root of negative 2 squared plus negative 2 square roots of 3 squared. So that's the square root of 4 plus negative 2 square roots of 3 times negative 2 square roots of 3 gives me 4 times 3, which is 12. So this is the square root of 16, which is 4. Our theta, the inverse tangent of negative 2 square roots of 3 over negative 2, which is the inverse tangent of square root of 3. Keep it in mind both x and y are negative, so I'm looking for an angle that is in quadrant 3. If we look at that relationship, square root of 3, that would be our square root of 3 over 2 all over 1/2. I'm looking at a pi over 3 angle. In quadrant 3, that is 4 pi over 3. So this angle is 4 pi over 3. So in polar form, I've got 4 pi over 3. Important to remember that if I were graphing that, and you can look at that polar graph down below us here, 4 pi over 3 right down here, up 1, 2, 3, that would be this point right here, which is in quadrant 3, the same way that our rectangular points coordinates are. So it doesn't matter as we convert from rectangular to polar or polar to rectangular, that point should still lie in the same quadrant. We are graphing the exact same point, just using a different frame of reference. Okay, so let us take a look at example 6. Going back to something we did on page 2, we're going to do it again. We want 3 other ordered pairs that have the same location at negative 5, negative 3 pi over 4. So let's start by plotting that point. Negative 3 pi over 4 is the same as 5 pi over 4. Okay, one thing that I want to notice, halfway around the circle is the pi over 4, and that's one of the things that we want to think about. If I'm moving in the positive direction, I am moving along this side. If I'm moving in the negative direction, I'm moving along this side. So to plot negative 3 pi over 4, here's my positive polar axis down here at 5 pi over 4, but I want to go negative 5, the opposite direction. So 1, 2, 3, 4, and I'm right here. That is my negative 5, negative 3 pi over 4. Okay. So I want 3 other ordered pairs that have the same location, and I want to start looking for patterns here so we can use that for B and C. So the first thing I've got to realize is that if I'm keeping my R negative, I need my polar axis to end up in the same place as that negative 3 pi over 4. So if I look at how I have this and what I've circled down here on the bottom, quadrant 3, that 5 pi over 4, negative 3 pi over 4 puts me in the same place as positive 5 pi over 4. So negative 5 pi over 4 is another ordered pair that ends up in that same place. Okay? Notice something. These 2 angles are coterminal. Okay, so 2 pi minus 1 gives me the other. If they're positive. Okay, so we know from what we did on the last page that I should also be able to write this with a positive 5r. Okay, now what I said earlier about this positive direction is 5 pi over 4, negative direction is pi over 4. That means this point right here can also be written as positive 5 pi over 4. This is where it ends up. Going in the negative direction, I've got positive 5, negative 7 pi over 4. So how do I say this? My negative 3 pi over 4 and my negative 7 pi over 4 are pi apart. So halfway around that circle to get from one to the other, it helps to be able to look at some of these relationships. And so let's see if we can use that for this next one. Change color so we don't get all confused. So I've got 4, 5 pi over 12. So 5 pi over 12 is marked on here. If I'm going up 4, the first ring is 1 away, the second ring is 2 away. There's my 3, there's my 4. So that's the point 4, 5 pi over 12. Now, I should be able to go, that is going in the positive direction. I know that I can also go in the negative direction. These have to be coterminal. So I'm going to go 2 pi minus 5 pi over 12. Let me put that down here. 2 pi minus 5 pi over 12, 24 pi over 12, minus 5 pi over 12, and that gives me negative 19 pi over 12, moving in that opposite direction there. Okay. And so now I should be able to write this with a negative r. These are negatives. And so halfway around the circle, 5 pi over 12 plus pi. So 5 pi over 12 plus 12 pi over 12 gives me positive 17 pi over 12. And if I take a look at that down here, I see that that is opposite, or pi away from my 5 pi over 12. And then I've got negative 4. So let's go that negative 19 pi over 12 plus pi. I get negative 19 pi plus 12 pi. and I get negative 7 pi over 12. So now realistically, let's take a look at this first one. I subtracted from 2 pi and then realized it had to go in the negative direction. I could have also done negative 5 pi 5 pi over 12 minus 2 pi. That would have given me the negative 19 pi over 12. Make sure you are cognizant of the direction that you are going so that you know you are on top of things. Okay. So let's look at our last one here. I got 8, negative 15 degrees. So negative 15, that's a pi over 12. I know that, here's my negative 15 degrees, if it helps to visualize. I'm going to try to do this without using that. So I know that with my positive r, I need an angle that's coterminal to negative 15. So I got 360 minus 15 degrees, and I get 335. So I know that 335 is coterminal to negative 15. Now I'm going to look for the two that have got negative r's. And so I'm going to take my negative 15. I am going to add pi to that. So I got negative 15. Pi is 180 degrees. I get 165, which makes sense. That's this one right here. So it's 165 going in the positive direction. If we go in the negative direction, (165) minus 360, I get negative 195 degrees. So sometimes that polar grid is nice to be able to visualize where your angles are. You can do this all mathematically, as long as you understand what those relationships are.